So today we will do the Laplace transform and its application in solving differential equation. So we will solve some first Laplace questions which we do in the last week also. So in this week I will just show you some questions on inverse Laplace transform. Then we will go to the its application in solving the differential equation. How we will solve the differential equation using Laplace transform. So let's take our first question. Okay. Hi, Sapna. So today we are going to solve some questions on Laplace transform and its application in solving differential equation. So you must have the seen that videos how we do the Laplace transform. Do you? Hello.
Yes, sir. So, what is the question?
A question is like in this session we will solve the Laplace transform and its application in solving differential equation, right? So have you seen this how to do Laplace transform? Actually, I also covered this in last session.
Okay.
So you must have seen that.
Yes.
Okay. Just 1 minute. Okay. So let's take first question. Uh, so Laplace transform, you know, right? So actually, for the solving the differential equation, we also have to know the inverse Laplace transform. So in this one, we cover one or two question on inverse Laplace transform. Then we will go to the solving the differential equation from the Laplace transform. Okay. So my first question is we have to find inverse Laplace transform of 1 upon s square plus 2s plus 9. Okay. So can you think about it? How we will proceed?
Yes, you will, sir. You will make perfect square of s square plus 2s plus 9.
Yes. Then
Uh, so this will become 7 s plus 1 whole square plus root 8 square.
okay. Okay. So you are right. First we will make uh, like we are considering it capital Fx. Okay. So inverse Laplace of capital Fx we will solve like sorry Fx is equal to 1 upon s square plus 2s plus 9. Okay. So what will be the perfect whole square of this one? This will be s minus 1 का whole square plus root 8 का whole square. Should I elaborate this or you can solve it? Can you solve it or I can elaborate this thing also?
Sir, I can solve it.
Okay, okay. So now what we will do?
So its answer will be 1 by root 8 e raised by minus t cos under root 8t.
Yes. So uh, see, if we consider this is our s and this is our a, then 1 upon s square plus a square, which function have the Laplace transform of like this?
So this will be 1 by a cos, I think it is cos or sine?
Cos of
Sine,
sine?
sine, not sine. Sine root 8t.
No, sine has 1 upon a upon s square plus a square, not 1 upon
So
s
that's
square
why
plus.
I said 1 by a.
Yes, yes, yes. 1 by root 8 we will, now we will, what
Yes,
we will do,
yes,
minus Laplace transform of 1 upon s square plus 2s plus 9. We can write this 1 upon root 8 and inverse Laplace transform out root 8
root 8
upon
upon
s
s.
minus 1 whole
Plus,
square plus
so
root 8.
plus 1, not minus.
mm,
So s plus 1.
S minus 1 will come, I think.
So s square plus 2s है ना?
Oh, okay,
So
okay, okay,
it will
okay.
be converted to s plus 1
Okay,
का whole
okay.
square.
Actually, this in question it is minus. Okay, then it will be minus 1.
Okay, okay.
Okay, sorry for that. So then Laplace transform we can write 1 upon root 8 and see this one is s minus 1, right? So first we have
Shift,
uh, that
the shifting property.
yeah, shifting
We use
property.
shift.
So e to the
E
power
raised to
x
power t.
and then
T or x.
sine root 8 x.
X.
Okay, this will be our inverse Laplace transform of fx. Understand?
Yes, sir.
So you have any question from your side?
Sir, please solve a question having the differential equation. How to solve differential equation which is non-homogeneous.
Which is non-homogeneous?
Yeah.
Okay, we will go step by step. Okay. So just one question I again solve for the inverse Laplace transform. Then we will go to differential equation how solve. Okay. So question two is inverse Laplace of s plus 4 upon s square plus 4s plus 8. Okay, again same technique, first we make whole square of this one, so we can write this like s plus 4 upon s plus 2 whole square plus 2 whole square. Okay, so next we have to what it is called partial fraction from this one. Okay, so we got from partial
So we can
fraction.
separate it
Sorry.
s upon. So we can separate it s upon s plus 2 whole square plus
Yes, yes,
2 का
yes.
square.
And
This will become e
okay,
raised by minus 2
what we will not do
cos.
like that, we will do s plus 2 we put in 1 1 and we put 2 upon s plus 2 whole square plus 2 whole square in 1. Is it right? Why
Okay,
we
okay.
do this? Because it is convenient, because in numerator we have s, sorry, denominator we have s plus 2. Okay, that's why I put this for using the shifting property. Okay,
Okay.
so if we use shifting property, so then we will get e to the power 2x, right? Sorry,
So
plus है,
minus
minus
2x
2x हो जाएगा, e to the power minus 2x and then it will go s upon this one, so it is
cos 2x.
cos. Okay, so cos 2x plus we will also shift property first then sine.
So
Okay,
sine
so e to the
sine
power
2x.
minus 2x and sine 2x. Okay,
Okay.
so next we will come, next we will come to Laplace transform of some differential equation. Okay, so how we will proceed? first we just take one step. So we know Laplace transform of a derivative. You know na, like Laplace transform of let's say d to the power ny over dx to the power n. How can we solve this? So just it will be s to the power n y Laplace transform of, sorry,
We can write y(s).
not Laplace, Laplace transform of y, okay, and minus s to the power n minus 1 y of 0 minus s to the power n minus 2 and y dash 0. uh, we will put like that, okay. So if we have some initial condition like at yx at x is equal to 0, okay, initial condition for that like y equal to 0 is equal to some constant c0, then we can find y dash 0 equal to c1 comma y n minus 1 0 equal to c n minus 1 like that. Then you can write Laplace transform of dny over dxn equal to s to the power n Laplace transform of y yx minus c0 s to the power n minus 1 minus c1 s to the power n minus 2 dot dot dot, okay. So this will be our case when we are solving the differential equation. So let's
Can
take
you solve some questions of assignments?
question of assignment. We
Because we
cannot
have
solve
already
like
studied for this.
that you will do by yourself. I will solve here some example, similar example,
Okay.
okay. So like
Okay.
question 1 I am getting y dash minus 5y equal to 0. This is our difference, simple differential equation at y0 equal to 2. Then how we will solve? So just take Laplace transform of whole equation, like Laplace transform of y dash minus 5y equal to Laplace transform of 0. Okay. If we have some function here, then we can take Laplace transform of that function. Okay. So if you follow the linear property of this Laplace transform, then you can write here a Laplace transform of y dash minus 5 Laplace transform of y is equal to transform of 0 will be 0, okay. So what will be the Laplace transform of y dash? It will be s and Laplace transform of y, okay, minus 5 Laplace transform of y equal to 0. So we can, sorry, minus 2 we will have this one, because if you take here n equal to 1, then we take s equal to minus 1 and then s to the power 0, some constant c0, right? So that constant will come to 2 when we using this condition y0 equal to 2, okay. So we now we can take this Laplace transform of by common, then we get s minus
Minus
5,
5
and this
equal
2
to
will
2.
go to this side equal to 2. Then Laplace transform of y we will get 2 upon
2
s
minus
minus
5.
5,
6 2 into e की power 5t by yx.
okay. So then we take the inverse transform, then yx will be inverse Laplace transform of y, okay. This will be inverse Laplace transform of 2 upon s minus 5, This will be simple 2 to the power 5x yx. Okay. You are saying inhomogeneous differential equation, right?
It's a non-homogeneous.
Non-homogeneous. You can tell some example.
Wait,
Let's say I will take some one question more. Just search. You have y double dash minus y dash minus 2y equal to 4x square. Okay. Then
okay,
y at 0 equal to 1, y dash at 0 equal to 4. We have two conditions here and we have to solve this. So again we take Laplace transform here. Let's say Laplace transform of y double dash minus y dash minus 2y equal to 4x square. Sorry, and Laplace transform of 4x square. Okay, so Laplace transform of y double dash will be s square. Let's say Laplace transform of yx is equal to capital Y x. Okay, so here we will get yx minus s minus 4. Okay, then minus s Laplace transform of this will be by x and minus 1. So minus 2 by s. Okay, this and the Laplace transform of this one will be 2 upon s cube. Okay, so from here we take ys common, will be s square minus s minus 2. Mm, this will be 2, right? Okay, minus 2 and sorry, we are taking common. Okay, so and this will be s minus 4 plus 1 minus s plus 4 plus 1 equal to 8y s cube. Okay, so here we will get by s square minus s minus 2 equal to 8 s plus 4 plus 1. This will be s plus 5 upon s cube. Oh, sorry. Mm,
okay.
sorry. 8 upon s cube plus s plus 5. Okay, so our ys will be 8 upon s cube s square minus s minus 2 plus
So y0 plus 1,
oh, this will be minus if you will take common
s plus 3 बनता है.
s plus 3 बनेगा ना. Okay,
Yes.
so s plus 3 upon s square minus s minus 2. Okay, now you can take inverse Laplace transform of this one, right? So inverse Laplace transform of by s is equal to 8 upon s cube s square minus s minus 2 plus inverse Laplace transform of s plus 3 upon s square minus s minus 2. So how we will solve this? Should I solve this full?
Yes, sir. Yes, sir. The first part, please tell me the how we will find the Laplace inverse of 8 upon s cube.
Sorry.
Do we have to use partial fraction to
Yes,
separate
yes.
these? Okay.
We have to
That
find the that one.
okay.
Okay. Our first part is 8 upon s cube s square minus s minus 2. Then first we should see what is this s square minus s minus 2. If we make some whole square, then what should be added and diffraction? First we make, because we have to factorize all these three, right?
So we can make partial fraction of it. That will be quite easy for
Okay,
us.
so this will be a upon s cube plus
As
b upon s square minus s minus 2, right?
so bx plus c because degree is 2
Yeah,
s square.
bx plus c. So now it will be 8 upon s cube s square minus s minus 2 a s square minus s minus 2.
Sir, where you have written a upon s cube, in fact it is a upon s plus b upon s square plus c upon s cube.
Yes.
Partial fraction, ascending order. We have to write it in ascending order.
Okay, you can do that also. Okay, so c b upon s square plus e upon s, right?
Yeah, now it is okay.
So if you take s cube, then bx plus c, and this will be s cube, right?
Yes,
And plus ds s square minus s minus 2 plus e s square minus s minus 2. Okay, now solve it. uh,
putting s equal to 0.
s equal to 0.
Yes, to find the values of constant.
Yeah, that we will put, but just compare like 8 equal to,
Or we can compare the coefficients also.
yeah, a s square. Here will be a s square, this one. Just find s square coefficient, right? So this will be a from here, and
Yeah,
from here it will, nothing will come in s square, right? In from this term, because this is s cube already. And s square, so minus d will come here from here, and s square minus 2e will be come from here. Okay, plus highest power is s cube, so what will be the coefficient of s cube? It will be c from here, and
the b
d from here, and this is s square, right? So no, we are taking s, so minus e from
mi-
here.
minus e.
Okay, and s square s cube. Now we will take s, so from s this will be minus a
Okay.
from here, and
Minus
min
2d.
sorry s है ना,
Minus,
minus 2d,
yeah,
and from here s
uh,
is s will be, s will not come from here, right? This will be s
yeah.
square already. Okay, and
Then
constant minus a will be from here, and
minus 2, minus 2,
sorry, minus 2a, minus 2a,
but
and
only nothing else.
nothing else, right?
Yeah.
And one as 4 term will also come from here, so this will be only b. Okay, now if you compare
Such
minus
E also,
2 is
I
equal
think
to,
E or E,
sorry, yeah, plus e.
C plus E,
Thank you. So b plus e, so minus 2 is equal to 8, so a will be minus 4. Okay,
4.
and all other terms will be 0, like v plus e equal to 0, so v equal to
Yes.
minus e, and c,
Let's say minus 3 equal to 0.
sorry,
Minus a minus 2D is also 0.
yes, yes, all term will be 0,
Here we
minus
get
a minus
minus
2t
2.
is equal to 0, so a will be minus 2t, so d will be 2. Okay,
Yes.
and next we will find e, a minus t minus 2 equal to 0, so 2e equal to a minus d, so this will be minus 4 minus 2 equal to minus 6, so e equal to minus 3. Okay, next, this term will 0, this
B is
already done,
also 3
so
because B
v
equal to
equal to
minus
3, so what else, c is left, right?
minus 6 and B equal to minus 6.
So it is 3, so
Yeah.
s cube, from here we can find c, so c plus d minus e equal to 0. Okay, so c will be e minus d, so e is minus 3, and
And
d is 2,
B is 2
so equal
minus
to
5.
minus 5. Now we can write this as 8 upon s cube s square minus s minus 2 equal to, a is our minus 3, right?
Yes.
Minus 3 upon s cube, and d upon s square, so d is 2,
3.
plus 2 upon s square. Now e equal to our, e is minus 3, so this will be minus 3 upon s, plus b, v is, v is 3,
E3.
and c is minus 5, so 3s minus 5 upon s square minus s minus 2. Now we will make the whole square of this one also, so this will be 2 upon s square minus 3 upon s cube minus 3 upon s, plus 3s minus 5, uh,
S minus 1 by 2 का whole square
s minus 1 by 2 का whole square. Next,
and minus minus 7 by 4
minus 7 by
minus
4.
7 and we can write it root 7 by 2 का square root
Okay,
7 by 2.
or I put root for whole.
Okay.
Okay, so is it right? I'm believing
Yes.
you. Okay, so now how can you, s minus half,
Yes.
so 2y s square minus 3y s cube minus 3y s plus 3s minus half, we are taking it as this one, minus 3 by 2 is coming now,
Yes.
and
plus
5
3 by
minus
2
3 by 2 and equals
minus
7
plus
by
3
2.
by
It is
7 by 2.
okay.
It's minus 7 by 2.
Minus 7 by 2, right? So we are taking this one in this one and minus 7 by 2 1 upon all these terms. Okay, this will be minus or plus. Hello,
Yes, yes, sir.
this is will be minus or plus.
So this is minus.
This is minus, right?
Minus, yeah.
So minus have some Laplace transform. What do you think?
See, this will become
A square, we have
cos,
to take
cos hyperbolic function. That will become a hyperbolic function.
okay, or we can take this a square minus b square is equal to a minus b and a plus b. Then we again have to do
So that will become a lengthy one.
very lengthy. Okay, so inverse Laplace transform if we are taking of this one 8 upon s cube s square minus s minus 2, then Laplace transform of s square will be 1 upon s square. This will be 2 into x. Am I writing right? Minus 3 s square. I think some constant is missing. Yeah. And minus 1 factorial will come means 1 factorial 3 and 2 factorial. So it will be 2 minus 3x. No, sorry, 3 will become only plus. Here it will come first this one e to the power x y 2. Okay, x y 2, then s upon this one. This will be cos hyperbolic and 7 by 4 under root 7 by 4. So under root 7 x y 2 minus this 3 will come here minus 7 by 2 is here and inside one a should be there na, so root 7 by 4 root 7 by 4 sine hyperbolic root 7 by 2 x. Okay, now this will be 2x minus 3 by 2 a- x square minus 3 plus 3 to the power xy 2 and cos hyperbolic root 7 xy2 minus root 7, then it will come root 7 e to the power xy2 sine hyperbolic root 7 by 2x. Okay, so this will be the inverse Laplace transform of our first portion, this one. Similarly, we can try with this one, inverse Laplace transform of s minus 3. Is it s minus 3, s plus 3, s square minus s minus 2. So
Sir,
again, huh,
sir, I can solve this. Can you tell me how we can take the Laplace of a piecewise continuous function?
piecewise continuous function.
Yeah, I'll
Mm,
question based on it or something else.
okay, Laplace transform of piecewise. I think I solved. Oh, I solved the continuous function, periodic function in the last thing. Piecewise function. Can you define?
Sir, in which intervals are given in fact? Uh,
Okay, okay, okay. I am taking one example. Just 1 minute. I think I solved this question in the like fx is equal to 1 and minus 1 in the interval x1 and 0, and minus 1 in x greater than 2 and less than 1. Sorry. Is it will be fine if I solve this question?
yes.
Hmm.
So it was like fx is equal to x square
Fx
and
is equal
x
to
is x square.
x square.
Yeah. When x, I want to remember the exact question. And next was the fx is equal to pi when x is not equal to 2 and 3. It was something like this question.
Something like that question.
So fx is equal to x square when x is equal to 2 and pi when x is not equal to 2 and 3.
Okay. X square when x is equal to
X equal to 2,
2 and
pi
pi
when x is not equal to 2 comma 3.
2 comma 3. Then what is the value of this function at x is equal to 3?
Not equal to 2 and 3 है बस आंसर ऐसे ही था
Because if you are saying this at when it means that if x is equal to 2, then x square. Okay,
yes
that is right. Then uh, and pi when x is equal to not 2, that is okay. But if you are also defining this is pi when x is equal to not 3, then what is the value of at x is equal to 3?
तो ऐसे ही था
Okay, because when if you go to the definition of the Laplace transform, so if we define Laplace transform of fx, then what is the definition? Definition wise, what will be here?
0 to infinity e raised to power minus sx
Sorry,
fx yes 0 to infinity
0 to infinity
e raised to power
e to the
minus
power
s
minus
x
sx function
or
of x
fx dx.
dx. It is the definition, right? So we know that the function at x is equal to 2 will be x square, and when it is not x is equal to 2 then it is pi, right? So
Yes.
our limit is break on 2, right? So you can solve it like 0 to 2 e to the power minus sx. So for 0 to 2 the function value will be pi, right? So it will be pi dx, right? Plus uh,
So
this will be
two
from
पे pi है 0 to 2
0 to
2
2. Yes.
fx is x square or pi.
Actually we will write here limit, like we will put here x, where x is limit tends to 2.
Okay.
Okay. And here limit when, sorry, not x, we will put some function, right, like r. Okay. Here we will put some function r and limit r tends to infinity.
Okay.
Okay. And then e to the power minus s x and function of fx, sorry, it will be again pi. Okay. And dx. Now only you have to solve this question, integration, like pi will be constant, right? So e to the power minus sx will be e to the power uh, minus sx upon minus s. Okay. Limit 0 to r plus limit r tends to infinity. Here limit r tends to infinity, integration 2 to r, sorry, again we will put e to the power minus sx upon minus s 2 to r. We are missing
So,
that at what
so
happens
what
at
about
two.
x square?
Yeah.
X
uh,
square.
x square is at x is equal to 2, right? mm, mm, oh, no, actually this type of question I could not solve now. At x is equal to 2 and less than 2 and greater than 2, then 2 to 3. Actually if one limit we have to like solve, we have to integrate 0 to infinity, and if we put limit like a to a then that integration will be 0, right? Or not? So this will be 2 to r, and if you solve this one, then it will be pi e to the power minus sr upon minus s minus this will be 1 upon minus s. Okay, plus actually some s condition will be also there for s is equal to greater than 0. If you solve, uh, this x square how could we include in this one? Actually we will see about this question, okay, and we'll tell
So
you, come back, okay.
okay, sir. Okay.
Hmm. Because there will be some condition for this special function like piecewise function.
Okay.
Otherwise, like if you have some question like if you have some limit, one limit to second limit, some other question, and then after that some other definition, that you can solve by this method by breaking this limit and then solve these integrals in the that limit. But it is happening only at exact s is equal to 2. Maybe it will be some advanced question. I will see and then back to you, right?
Okay, sir. Okay.
Okay.
Thank you.
Okay. So where we were. Any other problem you want? So next we will take one question. Question one: Laplace transform of gx if gx is equal to 0 to x square when x less than 4 and x greater than equal to 4. Okay. So first we will write fx such that like f x minus 4 will be x square. Okay, so agar then if we find such a function, then gx can be written as ux minus 4 into fx minus 4. Okay, so fx will be fx plus 4 and minus 4. So you can write x plus 4 का whole square equal to x square plus 8x plus 16. Okay, so Laplace transform of this fx will be Laplace transform of x square plus 8 Laplace transform of x plus 16 Laplace transform of 1. Okay, so it will be 2 upon s cube plus 8 upon s square plus 16 upon s. Okay, so it follows like L of Laplace transform of gx will be Laplace transform of u x minus 4 and f x minus 4 will be e to the power minus 4s and 2 upon s cube plus 8s square plus 16 upon s. Okay, so this one is the another method to solve it is called convolution. Okay, like similarly if we take one more question, like we have gx at 0 x less than 4 and x minus 4 whole square at x greater than 4. Okay, so first we define one function fx equal to x square. Okay, then gx will be ux minus 4, this is u, and f x minus 4. Okay, so it will be ux minus 4 and x minus 4 का whole square. Okay, then Laplace of fx you can write 2 upon s cube. So Laplace transform of this gx you can write Laplace transform of ux minus 4 and fx minus 4, oh sorry, x minus 4 whole square. Okay, so it will be e to the power minus 4s 2 upon s cube. Okay,